So here's my 2002 Honda CR-V, and the blower fan stopped working. So it stopped working entirely. No setting worked at all. The other stuff still lit up and seemed to work, and I needed to diagnose what the problem was. So basically in this vehicle you have a blower motor under here in the glove box. You have a relay, you have some fuses, and then you have this heater control panel, which basically has a computer behind it. And so let's take a look at the chart for how this is all wired up. So here's a schematic. Basically, here is the blower motor itself. The power is coming from this side and goes through a fuse, a relay, the blower motor, and then the ground comes out. And the ground is controlled by a transistor, which in turn is controlled by the control panel. The way I tested it was jumping these two, the black ground to the body, and then the black and blue ground that goes to the blower motor circuit, through the motor, through the relays and all that. And when I jumped this, turned the car to the on position, the blower motor came on full, which told me the motor's working. It told me I was getting power all the way through here, that the relay the power was passing through was working, and the fuse was also working. And then there was also another fuse specifically for the relay, but it told me all that was working. So the question was, is it the transistor, is it the control module, or is it a connector somewhere in here? And I checked the actual wiring itself, and that was continuous. So it could be a possible connector, but these transistors go out fairly often. So let's take a look at the transistor, and I'll show you how I repaired it. You could also just replace the transistor for about $50. Okay, right here is the blower motor. You've got a connector for the blower motor back here with a white and blue wire bringing power to it, and a blue and black wire taking the ground away from it. You've got the transistor up here. There's two screws which are very difficult to get to. You'll have to get a small stubby Phillips screwdriver. You've got a connector to the transistor. This is where I jumped the wires. I jumped the black ground wire to the chassis and the blue and black wire which is coming out of the blower motor. This transistor has two other control wires which go up to the heater control panel or module. To do any testing up here, you'll have to take two screws out. Before you do that, you'll have to take the cubby out of here. There will be one screw in the back. It'll pop straight out. Pull down the parking brake all the way down so you have room. Take these two screws out and then carefully pop this out. It'll have some clips. And there's a connector on the back, and if you find the same colors, the two control wires coming out of your transistor back here, you can test for continuity at one end of the wire here and at one end down here. You can also test for a short to ground by testing for continuity between that wire and a ground connection like that one back there. So whether you want to go into that detail is up to you. So here's the transistor once you pull it out of your car. You've got your point of connection here, your screw holes. There are 4 tabs which you can just go in with a pair of pliers and pop those off, and this is what you'll find: a little circuit board with your connectors. Under that you'll find the actual transistor and a temperature fuse, which is possibly the problem. So what I'm doing now is I'm desoldering the transistor and the fuse with this soldering wick. So I heat up the solder and then soak it up in this wick, which has flux, so it should attract the solder once it gets hot. And once I get it loose, I'm going to unclip it from the housing and get to the transistor below. Okay, so I've desoldered the board, and as you can see, there is a transistor with 3 pins. The one on the left is the gate, and I'll measure the resistance between the gate and the drain, and the gate and the source, which is this pin and this pin, and then I'll switch the leads around and measure it backwards. I'll also measure the resistance on this fuse. And so if I get infinite resistance on the fuse, that tells me the fuse is burnt up. I should get infinite resistance in both directions between these two pins, and infinite, or close to infinite resistance in both directions from the left pin and the right pin. So let's go ahead and test some of those. And the gate, drain, and source are labeled on the board, which I took off the top. So these two, nothing. Switch the leads around. Still nothing. And the other two, nothing. Switch the leads around. And nothing. Go ahead and turn up the resistance on my meter and see if that makes a difference. Nothing there. Nothing there. And by the way, this means that the transistor is good. Yep. So if the transistor is good, why did this stop working? Let's try the fuse. And so this should get infinite resistance, or should have continuity, should not have resistance if it's working. And we have no continuity this way, and no continuity this way. So what that tells us is the fuse has burnt up, and that's what we'll replace. Okay, so what I've done is I've taken this screw out, removed this fuse, which is right here, the old one, replaced it with a new one, which comes in the package like this, and I just made sure the numbers matched up. I'll include a part number in the description below. And so I took that screw out, which has a holder which holds down the fuse, and pulled out the old fuse, put in the new one, bent it to shape, trimmed it to length, and put heat sink compound around it. Put the holder back in, test it for continuity, and I do have continuity. And now I'm going to solder back on the connector and the board. Now, tin the solder and heat up the pin or the end of the fuse, and now flow it around there. And it looks like I've got a good joint. Got enough solder already on there, I shouldn't have to tin it again. Heat up the part, flow it around there, and I'm good. Make sure I have a good joint and it's not a cold solder, which means the solder doesn't actually bind to both sides, just kind of makes a lump. That's what we don't want. Now for the ends of the transistor. So there we go, it's soldered back in, it's clipped in. On the right side you can see some burn marks on the board from the soldering iron, but that's no big deal. And we'll go ahead and install it in the car and see if it works. Victory is mine.